Next thing we'll do with systems of equations is we're going to use substitution to solve them. So the goal here is we're going to use algebra and something called substitution to be able to solve for the variables. So the idea behind substitution, and this is the first of two different methods we're going to do, is you want to solve for the easiest variable. So look through the system of equations, figure out which one would be the easiest to solve for. Then, once you figure that one out, plug that into the other equation. You'll solve for a variable there, and then go back to find the first one. So our first example, let's go ahead and solve this. So we have x equals 5 and y equals 2x minus 3. So the first step of substitution was to solve for one of the variables, but we already have that. I already know that x is equal to 5. So once I have one of my variables solved for, I'm going to take that and plug it into the other equation. So I know that x is equal to 5, and I'm going to take that information and plug it into my other equation. So instead of writing an x, I'm going to write a 5. So then y is 10 minus 3, which is 7. So now we have x equals 5 and y equals 7. So our solution is 5, 7. Now we have one that's a little bit tougher. I have 2x minus 3y equals 7 for my first equation, and then y equals 3x minus 7 for my second equation. So first thing I want to do is solve for one of my variables. But we already have y solved for on my second one. Y is by itself. So that's my first step. We've solved for one of the variables. Then I'm going to take that information and plug it into the other equation. And what I mean by that is, instead of writing this y, I'm going to replace it with 3x minus 7 because they're equal. So 2x minus 3, and I'm replacing this y with 3x minus 7, and that's equal to 7. And now we'll go ahead and solve this. So I'll distribute my 3, which gives me negative 9x plus 21. So all I did was distribute the 3 from that last step to this one. Next, I'm going to combine my two x's. So that gives me negative 7x plus 21 equals 7. Then I'll subtract 21 from both sides, and I'll continue over here. So I get negative 7x equals negative 14. And then I'll divide both sides by negative 7. So x is equal to 2, which is half of our answer. Now to figure out what y is, go back to that first equation. Y is 3x minus 7. Well, if I know that x is equal to 2, I can go ahead and just plug in 2 to this equation to get y. So 3 times 2 minus 7, which is 6 minus 7, so negative 1. So x is 2, y is negative 1, which means my solution is 2, negative 1. A little bit of a harder example here. I have 3x plus 2y equals 1 and x minus 5y equals 6. What I want to do is figure out which of these variables is the easiest to solve for. So this x, this y, this x, or this y. And when I say solve for, I mean get it by itself. I mean, you can really do whatever you want, but most people try to avoid fractions. So I'm going to solve for this x. So if I get x by itself, I'll get x equals 6 plus 5y. Now that I've solved for one of the variables, I'm going to take that and plug it into my other equation. So instead of writing this x, I'm going to write 6 plus 5y. So 3 times 6 plus 5y plus 2y equals 1. So we'll distribute this 3 and get 18 plus 15y plus 2y equals 1. I'll combine my y terms. So 18 plus 17y equals 1. Then I'm going to subtract 18 from both sides. So 17y equals negative 17. And lastly, divide both sides by 17. So y equals -1. But again, that's only half of the solution. We need to figure out what the x value was. So what I'm going to do is take this y value and plug it into my first equation. So x is 6 plus 5 times -1, which is 6 minus 5, so 1. Which means my solution is x was 1, y was -1. Now let's look at y plus 4 equals 3x and 2y minus 6x equals -8. Just like we did before, figure out which variable is the easiest to solve for. So this y, this x, this y, or this x. Because there's no coefficient in front of that first y, I'm going to solve for y using that one. So y equals 3x minus 4. And what I'm going to do with that is I'm going to plug it into the other equation. So my other equation was 2y minus 6x equals -8. Instead of writing this y, I'm going to replace it. This is the substitution part. So 2 times 3x minus 4 minus 6x equals -8. Hopefully you see a pattern here. We're going to distribute that 2. So 6x minus 8 minus 6x equals -8. The 6x's are going to cancel and end up with -8 equals -8. So this is interesting. My variable went away. And what that means is that there are infinitely many solutions. So if you get a true statement like this, that means that there are infinitely many solutions. The solutions are any variables or any values that satisfy y equals 3x minus 4. So the solution to this is any x and y where y equals 3x minus 4. Basically what happened here is that these two equations are the same equation. Really just one is 2 times the other one. So there are infinitely many solutions here, any solution where y is 3x minus 4. So one solution could be x is 0, y was -4. All I did was plug in 0 for x. Another solution would be x is 1, y is -1. Another one could be 2 and 2. And these go on forever. There's infinitely many solutions to this system of equations. So if you get some sort of statement in the end that's true like this, infinitely many solutions. As an aside, if I would have got something like -8 equals 2, well, that's not possible, so there would be no solutions.